Hello teachers, welcome back to section 11-2. Just a couple of homework examples, less than 5 minutes of your time. The pentagon has only two diagonals that intersect at a given vertex. Determine how many diagonals intersect at a given vertex in each of the following polygons. I won't even do all of them. I just want to take a look at the hexagon and the decagon, and I think you'll get the point and be able to do this on your own. So let's just draw a diagonal. So hexagon, we're going to go from here. That's 1, 2, 3. I can't draw one there, right? Because that's the same line. So a hexagon from any particular vertex, you can only draw 3 diagonals. Now that doesn't mean all the diagonals. That just says at a given vertex. To determine how many diagonals intersect at a given vertex in each of the following polygons. So that's all we need is 3. So let's look at a decagon. So a decagon, remember, has 10 sides. And so when I draw, I can't draw there, but that's 1, 2, 3, 4, 5, 6, 7. So think about a pattern for that. So a decagon, you're going to have 7 diagonals from each vertex. Okay? So maybe you can, that'll help you do the other 2 when you do those in the homework. Now, this problem is very similar to the last one. Determine how many diagonals each of the following has. I'm just going to look at an octagon. You can handle whichever problems come up for you. Now, this is diagonals total. This is not just talking about from one particular vertex. But if we look at it from one particular vertex, maybe that'll help us out all the way. So if I just look at this particular vertex, that's 1, 2, 3, 4, 5. So on an octagon from a particular vertex, you can draw 5 diagonals. Okay? And then for this one, again, we could do 1, 2, 3, 4, 5. Right? Let me change colors again. From this one, I could do 1, but I've already done that one, right? And then 2, 3, 4, 5. Uh-oh, one disappeared. There we go. Let's put that one back. And that one's still there too. So think about a pattern of what's happening. So I'm doing, have you noticed, it would be the octagon. There's 5 from each vertex. If I go back to the last question, for a hexagon, which has 6 sides, it's 3 for each vertex. For a decagon, which has 10 sides, it's 7. So it's n minus 3. Okay, so for each of these, it's octagon 8 minus 3. So per vertex, again, my pen is still not working properly. It's 8 minus 3, which is 5. Okay, so we would have that for every vertex. How many vertices do we have? Times 8. Okay, so 5 times 8. But remember, when we drew one, we had already run into it. Won't that happen for every single one of them? Like there's 2 vertices associated with that. It's like when we get over here associated. When we get over here, that one's going to connect back up with one we already drew. So what if we divide that by 2? So it's the n minus 3, which is 5 per vertex, times the 8 vertices, but half of them we've already going to draw from another vertice. Okay, so divide that by 2. That's going to give me 20 diagonals. See if that'll help you with the other 2. Okay, that's the only homework problems I picked out. If you feel like you need to see more, and they can be tough, I know this, right? They can be tough, but work through them, see what you can do with it, and if you get super stuck, let me know. I hope you have a wonderful day.